Hello, we are here again to continue our journey. In the previous video, we took a tour of time, a primitive time in which we asked our first questions about the universe and became aware that we inhabit a world that we don't know completely. As the human being has been understanding the behavior of the universe, he leaves behind the mythical ideas and gives him greater emphasis on observation. They sought to explain the cosmos based on the movements of the stars. Let's go to the 4th century BC, when the first ideas formulated theoretically and philosophically by the first Greek sages and philosophers of the time emerged. Although they had to deal with religious beliefs, they relieved of the first two theories as geocentrism and heliocentrism. Although both were contradictory, they laid the foundation of modern science and cosmology. Let's visit Aristotle, a philosopher Greek scientist in 340 BC, who proposed the model of geocentric system. His theory explained the movement of celestial bodies as a function of position of our planets, proposed that the Earth was spherical and rotates on its axis, but remains motionless in the center of the universe, and at the same time it's surrounded by 8 concentric spheres that transport the Sun, the Moon, and the 5 planets known at the time. It was thought that the planets dragged by spheres that move in perfect circles around the Earth, and that the last sphere contained the fixed stars that are always in the same positions, one respect to the other, and also thought that the universe was finite, that it ended in the sphere of the fixed stars. In the 2nd century AD, this theory was completed and reinforced by Ptolemy, a Greek astronomer, mathematician, and geographer. In his book, The Almagest, he completed various theories of planetary motions, including the use of epicycles, difference, and equants that help describe orbits. It was acquiring more complexity since it was in force for 14 centuries, but the discovery of the laws of celestial motions and the improvement of observations made it increasingly difficult to support its validity. Moving a little further in time, in the year 1543, the heliocentrism theory emerged, proposed by the Polish priest Nicholas Copernicus, who, for fear of being accused of heresy by the Catholic Church, published his model almost before his death. His idea was contrary to geocentric. They changed the model of the system. He proposed that the Sun was at the rest in the center and that the Earth and the planets moved in circular orbits around it. This model described on Earth 2 types of motions, one of rotation itself and one of translation around the Sun. And around the solar system there is a sphere with fixed stars, and that the universe is finite and ends in the start of the fixed sphere. Almost a century later, Copernicus' idea was taken seriously. 2 astronomers, the German Johannes Kepler and the Italian Galileo Galilei, began to publicly support the Copernican theory. In 1609, Galileo began to observe the night sky with the help of a telescope, an instrument he had just invented. He discovered several satellites or moons orbiting Jupiter, showing that not all things orbit the Earth as Aristotle and Ptolemy had thought. At the same time, Kepler had modified Copernicus' theory, suggesting that the planets did not move in circles but in ellipses. After discovering that the orbits were elliptical, he could not reconcile this with his idea that it was magnetic forces that caused the planets to orbit the Sun. Then, Newton, in the year 1687, proposed an explanation for it in his work called Philosophia Naturalis Principia Mathematica, in which he not only proposed how bodies move in space and time, but also developed mathematics to analyze these movements. With the help of the law of universal gravitation, this said that every body in the universe was attracted to any other body by a force that was more intense the more massive the bodies were, and the closer they were. Newton showed that according to his law, gravity causes the Moon to move in elliptical orbits around the Earth, and the planets to follow elliptical trajectories around the Sun. This has been all for today, dear time travelers. It has been a very exciting trip. We are just warming up. We still have a long way to go. See you on our next adventure.